Here in this section, we have polynomial inequalities. So here we have examples for inequalities: x cubed minus 5x greater than x squared plus 7. Or another example for inequality is 4x minus 3 less than 9. And here we have 5x squared minus 3x plus 2 greater than or equal to 0. So all of these are polynomial inequalities. Second degree polynomial inequalities in one variable are called quadratic inequalities. To solve polynomial inequalities, we often focus attention on where the outputs of the polynomial functions are positive and where they are negative. So we have to see where they are positive or negative. Example: solve the following polynomial inequalities. Use set notation to answer. So number 1, we have x minus 2 times x plus 4 greater than 0. So here on the spot we have greater than 0. That means that this one is positive. First, solve x minus 2 times x plus 4 equal to 0. So what we have here, x minus 2 equal to 0. Solving for x is 2. X plus 4 equal to 0. Solving for x is negative 4. So we have x2 or x negative 4. These 2 points are critical points. Now here I have this table, and these numbers on top are critical points. We have the smallest number on left and the largest number on right. This is the same as number line. So this negative 4 was the answer for x plus 4. So here I use this circle to show that this is the answer for x plus 4. So x plus 4 equal to 0. The answer for x that we have here on top is negative 4. Then x minus 2 equal to 0. The answer that we have for x is here on top, that is 2. And what we should have for this inequality is greater than 0, and that should be positive. So I have this one here. And now use any number that is less than negative 4. For example, negative 5, which is less than negative 4. Use that one here on the spot. Negative 5 minus 2, that is negative 7. So it's negative number. Here we have negative. Then number between negative 4 and positive 2, for example, 0. Use that number here instead of x. So we have 0 minus 2. Again, we have negative number. Then any number greater than 2, we have, for example, 3. Use that 3 here instead of x. So 3 minus 2, that is positive. So here we have, it's positive 1, so that is positive on this part. So it changed from negative to positive. Now, you can use same numbers here for x plus 4. So we have negative 5 plus 4. Negative 5 plus 4, that is negative. And then 0 plus 4, that is positive 4, so it's positive. 3 plus 4 is 7, so that is positive. So we have all these negative and positive. Now here on this part, we have x minus 2 times x plus 4. So we have to multiply. So multiply these to find what we have here. So starting from left, here we have negative times negative, that is positive. Then we have negative times positive, that is negative. And positive times positive, that is positive. And our answer here should be positive. So what we have here, our answer is this part and this part. So x less than negative 4 or x greater than 2, that is what we have to use in solution set. So another method is using this number line. I have negative 4, positive 2 here on this number line. Using 0 here, and then plug in that here. We have 0 minus 2, 0 plus 4, so we have negative times positive. That is negative here on this part, so that is false, because our answer should be positive, but here we have negative, so that is false. And then any number that is greater than 2, for example, using 3, 3 minus 2 is positive, 3 plus 4 is positive, so positive times positive is positive, so this part is true, that will be our answer. And then using negative 5, which is less than negative 4, on this part, negative 5 minus 2, here we have negative, negative 5 plus 4 is negative, so negative times negative is positive, and this part is true. So our answer is what we have here or here. So the solution set is x such that, how you view it, this one is that here, this one is such that, so we have x such that x less than negative 4 or x greater than 2. Now here on the example, x squared plus 110 less than or equal to 21 times x. So first writing this in standard form, we have x squared minus 21x plus 110 less than or equal to 0. Then we have to factor. So here we have x minus 11 times x minus 10 less than or equal to 0. Next step, we have to solve. So x minus 11 times x minus 10 equal to 0. Solving for x minus 11 equal to 0, x is 11, or x minus 10 equal to 0, x is 10. And here on this part, this one is asking for negative. So here on this part, x minus 11, x minus 10, here on left, multiply, the answer should be less than or equal to 0. So on top, on this part, we have 10, positive 11, so the smaller number on the left and the larger number on the right, same as number line. Here 10 is the answer for x minus 10. And here we have equal to 0, so I use this closed circle. And 11 is the answer for x minus 11. So here, any number less than 10, for example, 0 or 9 or 8, it doesn't matter what number you use, it should be less than 10. So here we're going to have 0 minus 11, negative, then between 10, 11, 10.5 minus 11 is negative, greater than 11, any number, for example, 13, 13 minus 11, that is positive. Then here on this part, 0 minus 10 is negative, 10.5 minus 10 is positive, 13 minus 10 is positive. And then we have to multiply, so negative times negative on the first column. Here we have positive. On second column, negative times positive is negative. Third column, positive times positive is positive. And our answer in this case should be less than or equal to 0. That is negative, so our answer is this part. So that is true. And I can do the same thing here on this number line. Here we have 10, 11. So our answer is this part. Because of having equal to here on this part, here I use bracket to show that it's equal to. So the answer is this one. Again, if we use 13, we're going to have 13 minus 11, that is positive. 13 minus 10 is positive. Positive times positive is positive. So this is false. Then here on left, for example, 0. 0 minus 11 is negative. 0 minus 10 is negative. Negative times negative is positive. So this is false. Here I can use 10.5. So 10.5, using this one, 10.5 minus 11, we have negative. 10.5 minus 10, we have positive. Negative times positive is negative. And the answer is asking for less than or equal to 0, so that should be negative. And here is the only part that is negative, so this is the answer, between 10 and 11. So the solution set x such that x between 10, 11 inclusive. Number 3, 13x times x plus 6 times x minus 6 greater than 0. So here on this part we should have positive. First solve for x. Then we have 13x equal to 0. Solving for x. X is 0. Or x plus 6 equal to 0. Solving for x. X is negative 6. Or x minus 6 equal to 0. Solving for x. X is positive 6. So these are critical points. And our number line here we have negative 6, 0, positive 6. Now use a number less than negative 6, for example, negative 7. And use that number here on top instead of x, negative 7 times 13, negative 7 plus 6, negative 7 minus 6. So negative 7 times 13, that is negative. Negative 7 plus 6 is negative. Negative 7 minus 6 is negative. So multiplying all these, we have negative. Then between negative 6 and 0, any number, for example, negative 2. So negative 2 times 13 is negative. Negative 2 plus 6 is positive. Negative 2 minus 6 is negative. Multiply all these, we have positive. Then a number between 0 and 6, for example, 5. 5 times 13 is positive. 5 plus 6 is positive. 5 minus 6 is negative. Multiply all these, that is negative. Then a number greater than positive 6, for example, positive 7. So we have 7 times 13 is positive. 7 plus 6 is positive. 7 minus 6 is positive. Multiply all these, this is positive. And here it's asking for positive. So here on this part this is negative, that is false. Between negative 6, 0, this is positive, so that is true. Between 0, 6, that is negative, that is false. And greater than 6, and that is positive, so this is true. So our answer is here and here. Based on that, solution set x such that x between negative 6, 0. So here we have less than, it's not equal to, because here on this part we do not have equal to. Negative 6 less than x, less than 0, or x greater than 6. And now number 4, for f of x equal to x plus 3 times x plus 1 times x minus 14. Find all the values for which f of x less than 0. So what we have here on this part for f of x plus 3 times x plus 1 times x minus 14 less than 0. Now solving for x plus 3 equal to 0, x is negative 3, or x plus 1 equal to 0, x is negative 1, or x minus 14 equal to 0, x is 14. So these are critical points. So here on number line we have negative 3, negative 1, positive 14. Use any number less than negative 3, for example, negative 4. Then negative 4, so use this one, negative 4 instead of x. Negative 4 plus 3 we have negative, then negative 4 plus 1, negative, negative 4 minus 14 is negative. Also all these we have negative. The next one between a negative 3, negative 1, for example, negative 2. And then use that here instead of x, negative 2 plus 3 is positive. Negative 2 plus 1, negative. Negative 2 minus 14, negative. Multiply all these. Here we have positive. Between a negative 1, positive 14. Any number, for example, 0. So 0 plus 3 we have positive number. 0 plus 1 positive. 0 minus 14 negative. Multiply all these. Here we have negative. Then any number greater than 14, for example 15. So 15 plus 3, that is positive. 15 plus 1 is positive. 15 minus 14 is positive. Multiply all these, here we have positive. And based on what is given here, our answer should be negative. So here this one is positive, that is false. Here is negative, that is true. Here is positive, that is false. Here is negative, so that is true. So our answer is here and here. Based on that, solution set x such that x less than negative 3 or x between negative 1, 14. So here on this part we don't have equal to, that's why here I didn't use equal to. Other example, we have x plus 6 squared times x minus 6 greater than or equal to 0. So here on this part we should have positive. So first solving for x, we have x plus 6 squared, so that is x plus 6 times x plus 6 and times x minus 6 greater than or equal to 0. So critical points are, here we have x as negative 6. So this one repeats. Again we have negative 6. Then we have x minus 6 equal to 0. Solving for x, x is 6. So these are critical points. Now here on this number line we have negative 6, positive 6. Any number less than negative 6, for example negative 7. Then use that negative 6 here on top instead of x. So we have negative 7 plus 6, that is negative. Negative 7 plus 6 is negative. Negative 7 minus 6 is negative. Multiply all these, here we have negative. Then any number between -6, +6, for example 0, use that 0 instead of x here on top. 0 + 6 is positive, 0 + 6 is positive, 0 - 6 we have negative number. Multiply all these here, we have negative. Then any number greater than 6, for example +7, then use that 7 here on top. 7 + 6 is positive number, 7 + 6 is positive, 7 - 6 is positive. Multiply all these here, we have positive. And based on what is given here on this part, it's asking for positive. So on this part we have negative, that is false. Here is negative, that is false. Here is positive, so this is true. So this part is our answer. So based on that, our solution set x such that x is greater than or equal to 6. So it's greater than or equal to 6. Here we have bracket. And that is because here we have equal to.